Hi, welcome to Pletronics. We're taking another look at a fixed frequency crystal oscillator. In this case, it's a low voltage PECL device. As you can see in our fixture, we've got our device in a socket on a test card. The test card was built in order to do an impedance match between the network analyzer and the physical device. Mismatches or problems in loading can create erroneous data on the phase noise signal source analyzer. So it's always good just to make sure you've got a good, clean impedance match. In this instance, we're measuring 10 Hertz to 40 megahertz. We're looking at jitter between 12 kilohertz and 20 megahertz. That's a standard range which was set up many years ago in the telecom industry. It's become fairly standard for a point of comparison between different products and different technologies to see how they compare. In this instance, you can see between the two lines, the 12K to 20 megahertz range, we've got an integrated jitter. In this instance, it's measuring 117 femtoseconds, which is pretty good. This is the Pletronics J series. Our J series is the newer versions of the ICs, which tend to have very good phase noise performance. When you're looking at phase noise, there's two things you should be looking at: close in and far out. How much attention you pay to either is really application dependent. Close in phase noise, which we're talking here, 1, 10, 100 hertz, a lot of that's dominated by crystal Q. In other words, how high the quality factor on the piece of quartz inside the device is. That can vary depending on whether you're a fundamental in overtone or in OCXOs. Different cuts of crystals like SC, a stress compensated piece of quartz, have very high Qs. So the phase noise floor on those become much lower close in. As you get further out, a lot of it's dominated by circuitry. The type of circuits you have, the processes they were built in, how well they were put together, how well the layout was done inside the package. The dominating force inside the far out is really the IC, the process, the layout and construction of the device. That's just a few of the things we look at when we're looking at the different technologies to say what works better in what application, and generically how we compare different technologies. If you wanted to use a PECL versus an LVDS versus a CMOS, obviously CMOS at higher frequencies wouldn't be necessarily the best choice because of the rise time and fall time and the noise generated off that and the extra current needed. So any questions? Please let us know.